Okay, let us back to see what we did steps. We proved that we need to prove this one, 1 square 2, okay. This left side, this right side. When n equal 1 square, just I'm repeating my steps, right? I'm repeating my steps. When n equal 1, you plug 1 in both sides. 1 here give you 1 in the left side, in the right side. 1 plus 1 plus 1, 2. Okay, good. Then 1 times 2 times 3 is 6, over 6 is 1. Now for n equal k, you get the formula. Where is n? We have n here, plus n here. I can add n here, plus n at the end. Whatever you find n, you put k. Whatever you find n, you put k. Now, the last one for k, now we have sk, right? Which is this guy, sk in terms of k. Now we need sk plus 1. We need the sum when we have one more. I'm going to leave this in blue. I'm going to leave this in blue. I'm going to tell you 1 plus 2 square plus 3 square plus k. And here, look here, I'm going to leave this empty. K plus 1, 2k plus 1 over 6. Now I'm going to add k. I'm going to see if this is true for k more. K plus 1. K plus 1. Right? K plus 1. Now square. Remember, we have what? Here is square. And we have to remember that we have square. And here what? Square. Remember, we have a square. We're adding a square because we're talking about the square. A square. Good. Good. Then the steps again you have to follow. When n equal 1, you did points. You plug 1 in both sides. 1 in this side mean 1 only, nothing else. 1 square. In that side, 1, 1, 2 times 1. If this both true, this true, this true, this true, and this true. Now n equal k, we add k square, which is changing n to k only. Now we're going to prove it for k plus 1. We add k plus 1 square, k plus 1 square. Now, leave this side. We're going to prove this side to see how this side. This side we know, this side, we're changing this side. This side, from the definition, it should be instead of n, k plus 1, right? K plus 1 from the definition, n plus 1. I'm going to remind you, n plus 1, 2n plus 1 over 6, right? I'm changing any n to k plus 1. K plus 1 plus 1 plus 1. You follow me? Right? And 2 k plus 1 plus 1 plus 1 over what? 6. You see, this is the left side. This is my left side. Right side, leave it to me. This is going to be k plus 1, k plus 2, and this 2k plus 2 plus 1 over 6. Then this is the left side. 2k plus 1, k plus 2, 2k plus 3 over 6. Okay, let me see if I can improve my right side in the same. This is my right side. I'm going to take my right side. If I can prove that my right side equal to this, then I'm right. What I'm gonna do, I'm gonna take this guy, k plus 1, in a different page. K plus 1, 2k plus 1, over 6, k plus 1 square. And to have the same denominator, we will put 6 here and 6 here. Okay, now look, how I'm gonna prove this one. My objective is to get this guy. Get this from that. K plus 1, k plus 2, then I'm true. Okay, let me just start doing this. K plus 1, 2k plus 1, over 6, because we have the same denominator, plus 6 plus 6 plus 6k plus 1 square. Look safe here. Can you see something safe here? And you will see why I repeat this. This x plus 1 and this one. I can take it as a GCF, right?
Yeah.
Because that we said it's worth it, right? It's good to admit your k plus 1 out. Good? Okay, what left from this guy? What left from this guy? If we take k plus 1, left only what? K and what?
2k.
Plus 1 and plus here what? 6 k plus 1. You follow me?
Yeah.
Over 6. You see that? From this guy, we took k plus 1, k plus 1, k took k plus 1, this out because this out, only k took, and this guy we have the square out, then everything is done. Let us simplify this. Now, okay, k plus 1, and here what? 2k square, you see that? Plus k, plus 6k, plus 6. Follow me?
Yeah.
2k square plus k, 6k plus 6. Now simplify this one. K plus 1 2k square plus 7k plus what? 6 over 2. Good? Now what we have to do to factor, look to this guy here, safe. Good? 2k, how we factor it? I'm gonna factor it in the side, right? You remember how we factor this? Who can remind me?
You multiply 2 to 6.
He said something nice. You multiply 2 and 6, right? Which is going to be k squared
Plus 7k plus 12.
plus 12, then 2 k and what?
Okay.
2 number multiplied to 12, 4 and 3, right?
Yeah.
4 and what?
3.
4 and what?
3.
Now remember the number we multiply is what?
2. So you
This
divide
2 here and 2 here. This becomes x plus 2, right?
Yeah.
And here, what you're going to do with the 2? Bring the 2 to the k. It's going to be 2k plus what?
3.
3. We call this AC method. Then k plus 1, stay k plus 1, right? This guy here, right? And this guy becomes k plus 2 and 2k plus what?
3.
K plus 2 and what?
2k plus 3.
K plus 2, right? And 2k plus what?
3.
Over what? What the surprise said? What my surprise now? What this? K plus 1. k plus 2 to k plus 3, right?
Yeah.
But this one here,
Same thing.
k plus 1, k plus 2, then the left side, when I add k plus 1 of this equation and add change into k plus 1, give me k plus 1, k plus 2 to k plus 3, right? When I add k plus 1 to the other side, which is k plus 1 square, I mean, right? And simplified it, I end up with what?
The same as.
Then the statement is true for n. The statement, right? True for n equal 1, n equal k, and n equal what? K plus 1. Thank you. I have time?
No.
Thank you and have a nice day. How's it? I need everyone to repeat this video as many times as he can to get the advantage. Thank you and have a nice day.